And now I'd like to introduce Mathias Verraes talking about design and reality.
Thank you, Marco. Oh, hi, good morning. So, yes, my name is Mathias Verraes, and I work at Aartling. We are a software consultancy, but we focus on software strategy, design, domain modeling, living the dream life, basically. There's a bunch of us here speaking, and we have a sponsor booth as well. Go check it out. I promised that I got this keynote before we decided to sponsor, so there's no funny business happening. So, I'd like to talk about a fallacy in how design works, and software design specifically, right? We seem to still believe in how we approach it, how we think about software design as a very linear process, right? As sort of an incremental process. We think of it as understand the problem space, right? Take that, figure out maybe possible solutions, and then implement that, and keep repeating that. What Agile did is sort of tell us to do that in smaller loops. Well, they told us to iterate, but it never really, I think the message never really landed, right? It's still embedded in how we think about software design at the low level as well, right? You may remember this from the old object-oriented books and advice. Find the nouns, right? You look at your problem space, you find out all the nouns in that domain, you capture those, and those are your objects, right? And then you have the car and the invoice and the this and the that. And then you maybe look for relationships, you maybe attach behavior to that, and that's sort of our model, right? I think that real problem solving, real engineering, real design doesn't really work that way. It's much more intricate. It's sometimes by creating solutions that we learn to understand more about the problem. And you've experienced this, I don't doubt that. It's just that we don't think of it that way very much. We're trying to structure that in a very linear process. Even if we're sort of implicitly or explicitly trying not to do that, I think it's still our underlying belief system. So I have some stories where I'm trying to show how that actually is, how that can actually work different. Right. Yeah, don't worry, I don't have slides, just think of this as storytelling by starlight or something. Because I get questions, oh, we don't see the slides. I just have some notes, that's why I'm looking at my screen sometimes. So, well, for starters, I want to talk a little bit about domain language and ubiquitous language. Right? We seem to equate those. I disagree. Right? Domain language is a natural language. It's the language that is used by the people in the domain. Their job is not to design a language or to build a very precise language. That's our job. Right? So they talk about things, it becomes very ambiguous, it's messy, it's very organic, right? It grows. It's a social language. It's within the group, people evolve a language that fits their needs, right? Whether it's well, like a good language or not, that's not really the point, right? It fits their needs in that point in time. They will adopt terms, they will abuse terminology, they will change it. They will use terms just because that's what it's always been called, right? So it's very much a natural language, right? One that doesn't evolve based on intention or purpose or anything like that. Ubiquitous language is the opposite, right? That's us. That's the systems designers, and I'm using that term very broadly, right? Anybody who has some meaningful impact on the design is a designer in my book. So engineers, testers, documenters, even project management sometimes. Well, you're laughing, but Conway's law, right? So that language is, we need it to be precise, right? We're engineers, we need something precise that we can use. Programming languages are very unforgiving right now. Miss a comma and it's a bug that will, crash your system, or hopefully your compiler if you have a better compiler than that. But we need a very precise language, and we are responsible for designing that language. We have to think about what that language looks like. So it's not a copy of the domain language. I think that's a misconception in the DDD world, right? Oh, we just grab that domain language. No, it's actually bidirectional, right? First of all, it needs to be an agreed upon language. So there has to be a communication with the people who speak the domain language. We have to figure out what will work. But we are allowed to change that language, right? We are allowed to figure out a language that will fit the purpose as opposed to just be like a superficial copy of it. And it's a language, right? It's not just terms, it's not just nouns, it's sentences, it's grammar, it's adjectives, it's idioms and expressions. Right? I could use words from the domain language in an English, grammatically correct English sentence and still say something that doesn't fit in that domain. You have to ask these questions. Right? How would you say that? If this goes wrong, how would you explain that? What's the sort of language you would use? And you draw from that, but it feeds back as well. Right? Well, let's get to the stories, right? My friend and, mentor, I could say, and since recently also my collaborator, Rebecca Wurzbrock, who you might know from responsibility-driven design. She was the first one to use driven design. She's still sorry about that. But she wrote some books in the 90s and the 2000s. And so I'm working with her on some clients. But this is an older story. She was working, I think, about 10, 12 years ago. I'd have to check it. But she was working with a company that builds hardware and software for sensors in oil rig platforms. Right? The way that these sensors work, right? Well, the whole oil drilling. To drill for oil, you need drills, of course, and they cause a lot of friction, as you can imagine, heat and friction and pressure and all this stuff. And what they do is they add something called drilling mud. They call it mud, but it's sort of a chemical substance, right? It's chemical composition. They put that in the holes, and it serves, on the one hand, as a lubricant, right, to reduce the friction. On the other hand, it's used as a carrier to push debris up, rocks and dust and whatever, right? So it's sort of pushed up. And what they do is, and I'm not an expert, right? I hope I get this right, but in real time, they monitor all these parameters like pressure, etc., and then they change in real time the chemical composition of this fluid to fit their needs, right? Oh, it's getting too hot, they might add something, or I don't know, something like that. Right? So that's sort of how this works. And this company was building tools and sensors and software and dashboards and all that stuff. And she was invited to help consult. They didn't have like a very specific problem, but they were trying to understand if they were doing design well and if they could improve and where next to go with this, etc. Right? So sort of I would say, a fairly healthy environment, apart from the fact that it's oil drilling. I'm not in favor of that, but that's so. She came in to help, and they were looking at things and sort of deciding what kind of problem they would attack first, and sort of getting a sense of the whole thing. And then an oil rig exploded in the Gulf. You might remember. So, of course, the team became like everybody in the industry, right? What's happening and trying to figure out what that was. In the beginning, you don't have a lot of information. They figured out that it was not their company's material that was used. It was a competitor. But still, the team started thinking about, okay, what happened? Could that happen with our stuff, right? Are there any things that we are missing? Do we have any oversights? And they started sort of, searching around and trying to understand and speculate, basically, what are the things that could happen. Right? Faulty equipment, sensors being broken, for example, the telemetry, the communications between the sensors or the various components, maybe the software itself. Right? So what you do in such a case, when there's any doubt, you start looking for scenarios. You start looking for examples. Right? What could happen? Tell me an example. How would that work? Like, and go really onto to the level of day to day, right? Get actual numbers. Don't say, oh, and then customers do this. No, find a specific customer and say, well, this customer would do this kind of thing, for example. Right? You look for the stories, you look for the scenarios, you look for, how it happens in the real world, is what they did. So when something goes wrong, right? What happens on an ORIC platform? Maybe it's a small incident, maybe it's a catastrophic incident, but alarms start blaring, right? There's lights flashing, people are running around trying to fix the problem. So it's a very sort of noisy, intense environment. Most of the time they're small incidents and they get fixed really, really quickly. But it's still a lot of a lot of impressions happening at the same time. So what people actually do is, when the alarm has been sounding for a few minutes, they will turn it off, right? Because you want to focus on solving the problem. And then what they started figuring out is that in the logs of the software system, well, figuring out, I mean, they knew that, but they started looking at that as well. What happened in the logs is it was reflecting this, right? The alarm goes off, and then a few minutes later, the alarm was turned off. This was correct behavior, right? This was working as specified. But if you start thinking about it, if there's a longer problem, a longer incident, they turn off the alarm and they keep working on it. The incident isn't over yet. The problem isn't solved yet. So the logs reflect that after 3 minutes, the alarm was turned off and the situation was finished, but it's not finished at all, right? It's ongoing. So you can think of this as a missing specification, which is true. You can think of this as a bug, right? The software is not logging correctly, right? The perception of the system itself is incorrect, right? It believes that the situation is over, but it's not, right? You can think of this as a bug, but I rather see that as a modeling problem, right? We mismodeled this. We didn't understand something well enough and didn't reflect it in our systems design, right? And the log is just a reflection of that wrong assumption, right? So you start doing this, you start doing this exploration again, right? And you start thinking, okay, what does this really mean? This new insight, right? That we believe now that our system is misrepresenting reality. How do we deal with that, right? These alarms are only indirectly connected to the real problem. The real problem is the incident, right? But the logs talk about the alarm, not about the incident, right? That's a misrepresentation, especially based on, this is a highly critical system, of course. So we need to be very precise about this stuff. So there's something missing. There's a concept missing that exists in reality, that doesn't exist in our model, and that actually doesn't even exist in our mental models, right? People don't think about it that way. They think about the alarm goes off, and we have to goes on. In Dutch it goes off, but in English it goes on. It's very confusing. The alarm sounds, right? So there's something in between, and that's, in this case, that small misrepresentation, that missing concept could lead to catastrophic consequences, so it's very important. So I said look for scenarios. I go one step further. Go look for the very awkward scenarios. Find the cases where nobody really knows how it's really supposed to work, right? We understand the system, we know sort of the happy parts, we know sort of the typical behaviors, but look for cases where it's really awkward. Yeah, I'm not sure how the system behaves or even how it should behave in that situation. There's a lot of useful information in there, right? That's pointing to something missing, right? So one example they came up with was, what if 2 alarms happen at the same time, right? You can only sound 1 alarm, but 2 incidents happen at the same time. So it's not really 2 alarms, it's 2 incidents happening at the same time. What is supposed to happen in that situation? Oh, well, that hasn't really happened yet. Yeah, we haven't really thought about that. Oh, it's not in the specification, right? That sort of situation. So, something goes wrong, an alarm gets raised, something else goes wrong, now what happens? So you can think of scenarios, right? You could say, oh, as soon as the first alarm is turned off, the second alarm is turned on. But to the people in that space, it's very confusing because they push the button to turn it off. It goes on again. Oh, try again. Oh, now it works. Glitch. Right? Bad contact or something, which is not what was happening. Or can you do, you can come up with things like multiple types of alarms, etc. But those, require more investment, of course. But they start thinking about what if there's different severities? How do we deal with that? What if the second alarm is actually more, or the second condition is more critical than the first, but the first is sounding the alarm? What do you do in those situations? What they start understanding now is that it's not just 2 alarms, right? It's 2, what at this point they call alert conditions, right? That term, of course, that's plain English, but alert conditions didn't exist as a term in their models, in their mental models, in how they talked, in the domain language, in the ubiquitous language. It didn't exist. Now they come to this realization, right? We need this missing thing. It may sound obvious to you if you've already sort of seen this model. Or now you just, like a lot of people in a situation like that, oh yeah, that's how I always thought about that. Well, that's great, but you never communicated like that, right? People think when you find a new model that very often when it's like the right model, it feels right. You feel like you've already known it. You say, like, why didn't we do this from the beginning? But nobody actually expressed that, right? Nobody managed to figure out that there was a missing concept and that it needs a name and to bring it forward. Once you have it, it's sort of hard to unsee, right? So we have now the condition that happens. We are in an alert condition now, and the alert condition triggers the alarm, right? We have a new concept in between the incident itself and the alarms, which is this intangible thing of alert condition. And now, of course, an alert condition can last longer than the problem it was solving. The alert condition can last longer than the alarm, right? You can see how these are two distinct things now, right? Still with me? Excellent, smart audience, I love it. So it's very important, right? It may seem subtle, but this is an invention from the designers, from the engineers, that reflects back to how the domain actually works in a way that the oil rig engineers, the people working on those platforms, hadn't thought about the problem, right? So it's a new understanding of the solution, a new idea that came up in the solution that sort of reverted back to the problem space, to the domain, right? We say domain-driven design, it's sort of a misnomer, right? Because design always affects your environment, or should, in fact. That's why we build it, right? To improve things, to create new possibilities, to enable things, right? We complain about coupling a lot, but the point of software is that we can interconnect everything, that we can get data from 50 sources and combine it into something more meaningful, right? That we can do business processes at the speed of light that connect a whole bunch of things that used to be very hard or impossible even in the paper world. So, you know, this new model, we can think about, like, is this actually a better model, right? Which is the first thing you should do when you have, you know, a good idea, because it might sound nice, it might be very wrong. In this case, right, alert condition, is it a better model? Well, it allows us to reflect better that two alert conditions happen at the same time, right? We have this edge case now that we can deal with, right? We can model two alert conditions happening at the same time. We can start using this to our advantage. We can start coming up with ways how we deal with situations now. What if there's two? Well, we could indeed have different alert conditions, quantify them, have different severity levels attached to them, which is nothing new for you, of course. But again, the point is that it was a new discovery in that specific environment, right? I'm using a very simple example because it's usually very hard to come up with, you know, or to describe case studies from really deep insights in very complex domains, because first you need, you know, 2 weeks to get yourself embedded in that domain. But so we can raise alert conditions now. We can solve the original problem as well, right? We can log the alert condition. We can log the second alert condition. We can log when they end, right? Maybe there's a specific switch or a button to turn off an alert condition and say, okay, this alert condition is now over. But entirely separate from that, we can still log our alarms. So we have a much richer log that reflects our real, it's not even reflecting our reality, right? It's our needs about how to interact in reality that are better reflected, right? So I think that makes it a better model as well. Another way to think about this is that this model is decoupling us, right? Originally, the critical condition, right? The thing, the sensor doing something, you know, finding too much pressure or too much heat or whatever, that was coupled basically directly, maybe not physically, right? But logically, it was coupled directly to the alarm sounding. Now we can decouple that. We say, well, this happens. That is represented as the alert condition, as that new concept we introduced. And then separate from that, alert conditions can raise alarms. Yes? Do you recognize that pattern, actually? I assume most of you are software engineers. Recognize something? Do you have a name for it? This is where you're supposed to wake up now. I know it's early morning, it's Monday. Want some more hints? So I'll repeat it, right? So you have something happening in the real world, the actual sensors measuring something, representing that as a description, right? We have an alert condition, it has this severity, it has these properties, and now we also sound an alarm to represent this alert condition. Events? Well, yeah, I mean, you use events to communicate between these things, right? That would be a very good way to solve it, but that's not what I'm looking for. Sorry? Lar? Incident. Yeah, I mean, it's an incident. Well, okay, you mean like in a production software system that we have incident? It's very much the same thing, right? This is why this is probably why this model makes very much sense to all of you, because you're used to the concept of incidents. And you have sort of pre-existing shared models in our whole industry. There, in that specific situation, they didn't really make that connection, but it's still not what I'm looking for. So, feedback loops, yes, no? Sorry? You'll have to speak up. Circuit breakers. Oh, okay. Yeah. You're looking at way too far. So, what this is doing is separation of presentation logic and domain model, right? It's that simple, right? The model, it used to be that the alarm is user interface, right? An alarm is just a user interface, a very loud one, but maybe not what you think of as user interface, but it is a user interface. It's representing something about the state of the system to the users, and it's coupled directly to the problem happening. Right? We've learned to not do that in software in the last 20 years. I remember early in my career that was everybody did that way, right? Just your code, especially in PHP, where I was at the time, where people would mix HTML and code and everything in one file. But so this is really like the alert condition is the model that describes the whole situation. The alarm is just the user interface representation of that. That's not how they found this model, right? But it's interesting to see how patterns are actual patterns, right? They return in different situations. This is called, actually noticing that sort of stuff is called domain independence, which is not sort of domain in DDD terms, but is seeing patterns and seeing concepts and seeing structures and processes in completely different domains that are unrelated and making the link, right? And seeing how they relate. So I'm not saying that this is how they discovered it, but it's how we can actually draw a lesson from that, right? We can now think of what other weird problems do we have that can be solved by thinking of it as, what if we separate presentation from logic, presentation from the main model? I just find this very interesting, right? To see these sort of patterns returning. But these things are not necessarily easily unearthed, right? I'm telling this as a quick campfire story, but in real complex situations, complex domains, it's very hard to find this. And then when you find this, they might sound very nice. Oh yes, this is a much better model, right? I get it now. This is how you need to do it. You still need to evaluate that. You still need to understand, is this actually a better model, right? So you try this sort of stuff, right? Does it solve all these weird edge cases? You look for edge cases, even the ones that you're never going to need or never going to solve for, precisely because they can point you to misconceptions in your model. I'm not saying you have to build for them. I'm just saying spend a little bit of time at the whiteboard figuring out weird edge cases, right? Asking people, but what if this and this and this happens? Oh, that would never happen. Yeah, but what if it happens? Well, there's no solution for it, but how would it have to work if we try to solve for it? It's much cheaper to come up with these things than have a wrong model in production for many years and then figure out that it doesn't work, right? Then it's like a 3-year budget plan. So that's, I find that fascinating. But moving on, it's the most fascinating thing about this for me is the reframing of the solution. The new insight in the solution gave us a reframing of the problem space as a consequence. People in the domain started using it that way, right? They started talking about it that way. Oh, alert conditions, right? They started changing how their own mental models as a consequence of our design choices. That's very, very powerful. very dangerous, very powerful. Right? Let's see. Are there any questions? I know I'm not supposed to ask questions, but are there any questions about this right now? Yes.
Before we had computers, how did they work could they handle to
So Christina is asking, before we had computers, how would they deal with this sort of situation? I don't know. I've been using computers since I was 8. I was the first person in my class that had a computer at home. I don't know how the world worked before that. I mean, it's fascinating how people did stuff, right? It's very, but I don't know. Any easier questions? All right. So, I have another story. It's a bit more involved, so I hope it will make sense. This is back in, must have been around the same time, maybe a bit later, 2012, maybe 13. I was just starting out as a freelancer, doing domain modeling and DDD and sort of trying to make a career out of that. And I was invited to work with a small company, a startup, and they were doing copyright claims. So for people who create content are basically owed money for when that work is being used, like music on the radio or art or whatever. Right? And this company was using event sourcing. That was actually why they invited me, because they were doing stuff with event sourcing. They were trying to figure out some stuff. They had some technical questions about it. So it was very much supposed to be technical consulting. And the way it worked, they had a bunch. It was a very small team, but they were working on doing those claims, right? Figuring out who to pay how much. The way that worked was that they would have different data sources, which could be anything. So it could be data from publishers, could be data from sort of wiki-style public sources, could be like from radio stations, etc. That sort of data. It could be individual claims from publishers or from content owners, right, authors, that they owned this work or that this work was being used somewhere. And so they were looking at all that data. And before that, well, here I do have an answer for the before computers question, because I also know how some of this worked in the Belgian Copyright Office, and it was the biggest pile of paper that existed, right? They were having lots and lots of people just looking over all this paper, and trying to figure out and having big boxes of files, basically doing this stuff. So human computers, basically, with all the pros and cons that entails. So the startup was trying to speed this up and make this more accurate and make this a much cheaper process. Of course, the promise being that the copyright holders would get their money faster, that it would be correct, that nothing would be missed, etc. Right? And do this at a much lower cost, and that would be sort of the competitive advantage of that company. And so, well, I was invited to work on technical problems on the event sourcing stuff, but being a DDD person, of course, I couldn't resist trying to understand how it worked and what they're trying to achieve, etc. And there was sort of this divide, right? The founders of the company were domain experts. They had high expertise in this whole copyright domain. The engineers were a technical team. But they were not, I think that's important to understand in these situations, right? They were experts in copyrights, but they were not domain experts in building an app or building a system to automate that, right? The fact that they're experts in one area doesn't make them experts in how that app should work. That concept didn't exist, right? There were no experts. They were inventing how to do that. So it's a very novel domain in that sense, right? which is always interesting because you're not just trying to capture domain language and turn that in a model and make that productive and maybe, but you're actually building a language for that. You're inventing how to think about the problem to begin with. Right? Which is, another sort of, the problem is in many startups, that sort of thinking work doesn't happen because, of course, they need to move fast, they need to prove a market, they need to get a product out there. They have like a runway of 18 months before the money runs out, and that's the reality. That's okay, right? I think that in such a situation, if you have a bad design, if it actually gets you to market and helps you find your product market fit and helps you get your A-series investment or something, it's actually it's a good design. Good design is always for purpose, right? It's good design because it helps you achieve that. If people say DDD makes you slow and we want to go fast, well, then maybe it's bad DDD, it's bad design, right? You didn't design to fit the needs of the organization. I do think that in the long term, DDD is going to make you a lot faster, right? Because you build up understanding about the system and the domain in the system's design, in the artifact, and that makes change much easier and much faster. Right? The way I think about a model, right? It's just like in science. In science, a model is something that helps you make predictions about natural phenomena. In software, having a good model allows you to make predictions about how the system will behave, right? That's what I meant with the, look for the awkward situations. Nobody could predict how the system would behave when two alert conditions happen at the same time. To me, that's an insufficient mental model about the system, right? And about the environment. And there's actually a second layer to this. If you have a good domain model and a good system model, right, you can understand how your system will behave under different circumstances and inputs. One step up from that is, how will it behave if we change something? Right? So if you have a good understanding and you can predict that this change will impact this and this and this thing, and we'll have to change it here and here as a consequence, and that is correct, then you have a good understanding. If you don't have that, that's why working in legacy software is so hard, right? Because every change you make, you have to do like reverse engineering to understand, first of all, where to make the change. You have to then understand what the impacts of the change will be, what the other 100 places are going to be where you need to change the system. That's very high effort and high risk, and a lot of changes don't even happen because they are so inhibitively expensive to do, to understand the impact of the change. So a good model actually gives us that predictability about the behavior, predictability about the changeability and the changes in the system. This company doesn't have that, as you can imagine. It was a very technical problem, right? They had all these different data sources. They would pull data from that, and they would do what they call data matching. Right? So you look at the data, and you look at claims coming in for either ownership or, it's a bit more complex because works can be owned superficially explained, but owned by the authors plus the publishers who maybe invested in that work and own a piece of it and have a right to royalties on that. And then the claims about the music being used by the users themselves, like radio stations and whatever, movies, whatever, and claims from the other side of the copyright holders that claim that their music has been used somewhere. So you have all these different claims. Some of these sources are public, like they could be manipulated, right? There could be fraudulent actors in this environment. Some of these sources are actually like high quality. My client paid for access to these sources, so you have a high expectation of the quality of that data. But they could have individual claims, they could have everything. So it's a big mess. They have a data problem, right? They have a data quality problem. And they had written a lot of code to try to figure that out. And that's what they call the data matching. The business people weren't really involved in any of this. They would just say, oh yeah, that's the data matching, right? That's the technical stuff. Well, we can't really do, we hired an event sourcing guy. I know you do DDD, but it doesn't really apply here. That's what I was told, right? This is not a domain problem or a domain modeling problem. This is a very technical problem, just all these data sources and filtering the data and pulling the data and formatting and interpreting it and applying these matching stuff. It was a very complex stuff and process, and only a few of the engineers properly understood it. And even properly, they believed they understood it well enough, but it became very messy very fast. And they think of it as not a domain or not a business domain. They think of it as a technical thing. I'm saying, well, this is how you decide who to pay and who not to pay, and that's your core proposition, right? This is your business. This is your core domain. So we start modeling, right? We go to the whiteboard. I call this guerrilla modeling, right? Where you're not officially mandated to do it, but you're like trying to sneak some of it in. I get this question a lot, right? How do you start with modeling if people don't allow you? Well, you don't call it that. You don't call it DDD. You don't call it event storming. You just say, hey, I have a question about this thing. You know this very well, right? You can flatter them a little bit. Actually, I'm from Belgium. I bring chocolates to this kind of situation. But it works. Actually, I have a story. I don't know if it's relevant, but do we have time? When do we stop? 20 minutes. Oh, yeah, we're fine. We're fine. So I was working on a software system that was going to replace the competitor's software system. But we had to have all the data from the competitor system and somehow get that in our new system. The competitor was not very excited about that. So there was always like this, they would be basically, well, I wouldn't say sabotage, but deliberately unhelpful, right? And at some point even, how was that? So there was like this SOAP-ish API, if you recall those. It sounds cleaner than it is. Sorry. But we had this maybe I should tell a bit more. It was a system for managing schools. There were it was the staff management part, so the teachers and everything. No, it was students as well. Students were in it as well. And then if a student, for example, had a sibling in the same school, there would be a line for the student, a line for the other student, for the sibling, and there would be a line for that relationship. In this one big XML file that we got from that API, right? It's just one big, basically the whole state of the system. And then if they had two siblings, there would be a line for every relationship. If they had two parents, that would be two lines, all in the same list, right? If they had divorced parents, there would be 4 lines. And then if you had siblings and divorced parents, it's like this combinatorial explosion of things. So what we ended up doing is trying to reconstruct what we thought was the underlying relational model for that big blob of XML that we got. And that was a lot of work and painful work until we figured out who the person was that was actually working on that API. And occasionally we got to, communicate with them a little bit. But then we were in Ghent and they were in Antwerp. We found a way to contact that one engineer directly. So we were sort of bypassing the whole official organization structure and everything. We found that person. We went over there. We brought chocolates. We had a good chat about life as a developer. We went back and things started getting fixed. So it was this stuff works. This story was not the copyright claim was not in Belgium, so we had to rely on other ways. But so the point is that the domain experts understand the domain. They don't understand the system that is being built. That's a novel, a newly invented solution. The engineers, limited understanding. Only some of them who really worked on that data matching, and no real model, no real understanding. We're doing some guerrilla domain modeling, right? We're doing finding a bit of time in lunch breaks and whatever to start modeling this. start asking the questions, right? What's actually happening? Tell me about it. Like find one of the domain experts and have them talk to us. What is supposed to happen, right? Why is copyright complex? What's happening? What do you do day to day, right? Or what did you do before you had this software? What was your job like? And they're talking about these claims coming in, and then based on if you get a claim from a source that you trust, and you get a claim from a source that you don't trust, like an individual or a public source might be less trustworthy and more liable to fraud. I'm not saying that there was a lot of fraud, right? But it's the potential for fraud and mistakes, basically, that they were trying to overcome. So even if you have two equal claims for one saying A and one saying B, right? They're opposite claims for the same thing. How do you decide which of those two you trust? Well, you look at the trustworthiness of the source itself, right? And you start comparing that. And then they started understanding that, in this conversation, we started sort of seeing that what the code was actually trying to achieve is look also at, because they had been trying to build for this, right? They had actually stuff for this in production. If a source was more trusted, they would value that claim more, and they were sort of looking at how can we do more of this where we also track how much we trusted something in the past, how much that trust was validated or not, and can we use that information, so historic information. So, for example, you give me a claim, I don't trust you, you're a new source, but your claim is corroborated by 2 other sources, my trust in you increases, right? So they were doing all of this with, thousands of if statements, basically. But I'm like paying attention to the language, right? Like, okay, you keep saying trust here. What's that, right? Let's write that on the whiteboard. What can we do with that? Let's do a thought experiment, right? What if trust was an object in our system? Right? Nobody thought of it that way, right? It was just, there's the claims, the data sources, the filtering, the matching, all that. But what if we turn that into something? And we start realizing, okay, we could do this as basically a value object, right? This trust represents the value of trust we have in that source or in that claim, and now we can model it that way in the code. So everywhere it was using values, right? It was using numbers to compare stuff. Oh, we have 2 claims and 1 claim, and historically you've had 100 successful claims, stuff like that. But we abstracted that into this value object called trust. First, just on paper, on the whiteboard. But then let's start trying this in the code. Let's do a little proof of concept. And this was working really nicely now. Instead of these naked primitives everywhere, we could start using this object. We started seeing the flow of things. We started seeing how this value object was being threaded throughout the code, right? It's hard to express the joy when you see something like that. Oh, wait a minute, this is working. Like, now it turns up here again. Oh, this whole block of code here is doing these values. Okay, here the values are a bit different, but what if we can mess around a bit and make it fit this little trust value object? And so, because the next step was that so we started doing that, and then they were doing event sourcing. So event sourcing is very suitable for what I call temporal modeling, right? Understanding processes as first-class concepts in your model, as opposed to structural modeling. Entities and then relationships, that's a structural model. Event sourcing, so events happening over time, processes as a unit of cohesion between events happening over time, that's temporal modeling. That allows you much better to think about processes, right? How things evolve, life cycles of things, how processes influence each other. Right? So we start looking at it that way. Right? What are the events coming in or happening that impact trust? How does the trust in you change? How does the trust in the source change? How does the trust in that specific claim change? So before, and that's also important to understand here, right? There wasn't a shared concept between what we now call trusting a source or trusting a claim. There wasn't a shared, or even trusting that a work exists, right? It could be a non-existent work that somebody made a claim for. So trusting, trust was the new glue between these different concepts that we had never sort of seen as one concept before. And now we start thinking about what impacts trust. What happens? What are the events? How do they change our value of trust? And when we start asking questions about this, the domain experts start getting interested. Because now we're talking about something they can understand, right? Trust and the impact of trust and the evolution of trust. They get really interested. They get fascinated by this. They come to these meetings. They're like, we didn't need chocolate anymore. they like coming now, right? Because it's their world. Data matching, they couldn't understand that. And even the engineers couldn't explain it. So, but trust they can understand. In fact, what happens at this point is that people from the domain start coming up with an arithmetic for trust. Right? They are coming up with the rules that say, well, I think we had a scale of -5 to +5 or something. So 5, of course, being fully trusted. But it's not because you have a claim for a source that you trust with 3 and another claim that you get that you trust with 2 that automatically is a 5. Because, basically they come up with a whole set of mathematical rules to say how trust changes, how much trust another source must have, and corroborate your claim so that you would gain more trust as a source as well. So they are actually inventing the math here. Right? It's still fairly simple arithmetic, but the point is that they did it and not the engineers, which of course I'm fascinated by again. I'm just summing up stuff I'm fascinated by in this talk. So this kept evolving, right? At some point, we started understanding how, there were still a lot of if statements, but we started understanding under what conditions, like what was the reasoning behind the if statement. Instead of the what, we started understanding the how and the why and the how often and the how frequently and who owns this and who decides this, etc. We start understanding sort of the different patterns and strategies basically for updating trust. Because in different situations, we assign trust differently. Right? We start modeling that in more detail. Basically, we end up with what I would call strategy objects. So the strategy pattern. So basically an object that represents a specific strategy for updating trust over time. Right? We have rules. Some of these rules combine in a strategy. Some of these rules and maybe other rules combine in a different strategy for a different situation. Could be a different country or market. Could be a different type of copyrightable work, different reasons. But we have these strategy objects, right? These are polymorphic, right? So Liskov's substitution principle, right? We can plug in a strategy in a situation, and the client code doesn't know how the strategy works, doesn't know the rules. It just tells it, apply yourself to this and give me an answer. So we get this very sort of flexible, movable components. This is what good, like a mature domain model looks like, right? You don't manipulate blocks of code anymore. You start manipulating components and abstractions. So adding a strategy here is really just adding another object of the same type. Most of the time, after a while, right, this object is just composed of rules that we already have. Right? So programming becomes sort of higher level, playing around with these abstractions. Right? So in a mature design, you're never, well, not never, but you're not really manipulating large blocks of code. You're adding things of the same type, removing things of the same type, reordering them, reconfiguring them. Right? You can imagine that some of these business rules maybe had parameters, or maybe the strategies had parameters, so you can configure those. So you get into this very high-level abstraction where you can talk about this stuff with domain. Even I don't think you ever got that far, but I've been in other situations where we could sit down with domain experts, look at the code, even though they were not very technical, but look at the code and see everything expressed in their language and as concepts that they could see and they could understand, okay, this is correct. Here, no, this is not actually what's supposed to happen, right? If the code can express that, it's very visible. What happened here, right? And again, what I find fascinating, trust is a metaphor. Right? They were using the word like almost randomly, right? Ad hoc, right? People would just drop that word in a conversation because it was the closest thing they had. They were talking about, claims and corroborating claims, etc., and trusting source. It's a metaphor because, well, machines don't trust each other, right? Trust is a human emotion. It's not very quantifiable, right? I might trust you. Maybe I trust you more if I get to know you, but it's not measurable, right? So this whole concept of trust here was very much a metaphor. It was something that didn't really exist, right? It's not a tangible thing. It's not like find the nouns and put an object in there, because it wasn't even considered as a relevant noun. It's not like a source. A source, they had an object for that maybe, right? And a claim, I think they came up with objects for that stuff. I don't recall. But trust, nobody even thought of it that way. Nobody, even though they used the language, nobody like recognized that they were using the language, right? So what I'm trying to show here is that reality was sort of non-existent. There was the copyrights domain existed for a long time. They had this code, but there was no reality that sort of tied it all together, because they were inventing the product. And then in the design team in engineering, we figured out this metaphor, which suddenly allowed us to click everything together, have like an organizing concept at the heart. I would say this was a creative invention at this point, right? We didn't invent the word trust or the concept at all, but applying it in a novel, creative way in that situation, even though the ingredients were there, but we hadn't noticed it at first. I think that is a very powerful way of looking at our job as software designers, right? How do we come up with solutions? The way you do that is come up with many solutions, right? And like try to break out of your preconceptions of what your solution should look like. Find these solutions, evaluate them, right? I have a link to a book where we have, Rebecca and I have an essay in there about how to evaluate models by comparing different models and trying to understand how one model has building blocks that another one doesn't have, and how they change our perception on the problem we're dealing with. So you compare these models, you figure out what works, what in one model helps you work that another is missing, and you use that, of course, to build better models. So that's because I'm now just sort of saying this as a magic story where somebody came up with trust and then everything worked. There were many models, right? There were many wrong paths. There were many ideas that failed. Some of them get dismissed fast, maybe too fast, some of them. Like try to not, what we do when we're modeling or when we're problem solving in general, we try to converge very, very quickly, right? That direction, I guess. So two people have an opinion. We try to agree on a single opinion as fast as possible, on a single solution, on a single model as fast as possible. No, like make a copy, make another version. Right? I'm using Miro a lot. It's very easy now. You just copy the whole thing. You have a new version of your model. You start editing. Label those models. Give them names. Okay, this is the trust model. This is the whatever model. This is Jim's model. And then if people are competing, if there's like this alpha male thing happening, and I've been guilty in the past, where you want your solution to win. It's the best one. It's yours. And the more you defend it, the more you can't let go, right? Even if it's wrong. What you want to do is sort of a bit of facilitation, right? You say, okay, we seem to have two conflicting opinions. Hey, can you explain your model? And let's visualize that, right? Let's write that, and you try to really capture their version. No interpretation, but okay, is this how you see this? Is this what you would call this? Is this where you would put this? Okay, let's do you. Is this how you would do it? Visualize that, and then instead of having these compete, you say, oh, you're both very good at coming up with models, right? Can you come up with a third one? Can you create more options, right? Can we think of it a different way? How would you solve it then? And then you can start comparing these things, and you get much more, powerful ideas. So go out there, right? You're engineers, you're designers. We create realities in software. It's very powerful. We can do that. We're gods, basically. So, we're not just building from specification, right? We have to invent things, be creative about it, be very disciplined about evaluating them, right? In music and in writing, we say, kill your darlings, right? If you have a great idea for a model, oh, this is a beautiful abstraction, but it's not the right one, get rid of it, right? They're not your children, right? You need to learn to let go of them. So, thank you very much. Thanks for listening. Enjoy the conference. And see you around. Thank you.